So good afternoon to everybody. Thank you for being here. This is the second webinar from the project 6G-VERSUS, a consortium, an international consortium that is financed through Horizon Europe. You find the link to our website in the top right corner. So just please visit the website and find all the main informations. We have regular updates of our work there and also in our social media. So for those of you who already were present in the first webinar, that was a month ago on the 26th of May, you already had the opportunity to get to know a little bit more about the consortium and the work. So in short, 6G-VERSUS is working on 6 case studies across Europe that we call the 6G-VERSUS clusters to implement different solutions using 6G. And one of the goals of the project is achieving sustainability through 6G. And so we have a dedicated work package that is led by SEJ, Center for Social Study. So I'm Rita Campos, and my colleague Bernardo Valente is also here to present a little bit of the work. And so today the webinar will be focusing on the sustainability dimensions of our work, but also how it is aligned with our technical implementation. So the agenda will follow 5 main presentations. The first one about this links between technical management and sustainability that will be presented by Xenofon Vassilakos, as our technical manager from ICCS in Greece. Then Bernardo from SEJ will present the overall overview of Work Package 6, that's the work package dedicated to sustainability assessment. And then we will have the 3 members from the partners that lead the 3 tasks from this work package. And each one is dedicated to one sustainability dimension. So Bernardo, again, from SEJ in Portugal, will present task 6.1 that is focusing on environmental sustainability. Shanaka Pereira from the University of Bradford and Mariam Irekiola from Kingston University, both in England, will present task 6.2 that is about social and cultural sustainability. And we have Theodoros Rokas from Insights in Cyprus that will present the overall goal of task 6.3 regarding economic sustainability. At the end of this webinar, we will have a 10 minutes period for open discussion and Q&A from the audience. So please feel free to use the chat and we will take note of your questions. This last part will not be recorded, so we'll stop recording after Theodoros' presentation. So this is just an overview of the highlights for each presentation, but I will not take longer and I will pass on the floor to Xenofon. Thank you all.
Thank you, Rita, for this kind introduction. Allow me please just a second to share my slides window. So hopefully you can see my slides. Hello, and thank you for this introduction, Rita, and thank you everyone for attending our webinar. I'm here to present to you not the technical details, but within the context of this webinar, the aspects of technical management when it comes to sustainability from a project perspective. So what is the key research question we're dealing with in our project? Sorry, that was unintentional. So the key question is, how can a 6G system future telecom system, jointly optimize both the technical objectives, the environmental and the societal ones, and also look into the economic outcomes across not just one vertical sector. We're not looking for a tailored solution, but across several vertical sectors. So for this short technical perspective presentation, we're going to start from the point of view that our project has been designed having sustainability in mind. Then we're going to dig a little bit into, scratch the surface to be more precise, on the management of trade-offs between performance from an application perspective versus the energy efficiency, which is one of the sustainability footprints. Resource utilization versus the environmental impact and so forth. So all the different trade-offs. When you're trying to improve one thing, it's usually coming with a trade-off against something else. And we're going to wrap up highlighting how we start from objectives in the designing phase of a project and how we end up in measurable outcomes. Having that said, what we do have in our project is a reference architecture, which is not what you see here. I'm going to show it to you in the next slide, which has been shaped after requirements. So by design, in our project, we started from gathering all the necessary requirements across the different sectors we're looking into. We shaped the reference architecture, and then we passed it to each and every site that has a dedicated vector use case to look into. They adopted the architecture, and they did choose out of the several options the technologies that matched the specific use case, and they're in the process of conducting trials. We've already been through a first year of trials in 6 different sites and 7 use cases, and proper evaluation. And we're going to finish our project next year with a last set of trials per site. What you see on your screen on the right part, and hopefully you can see my mouse pointing, is what we call the 6G application. The 6G application is one unified thing, but it is composed by 3 different applications. The vertical application, or if you want, the traditional service. The network application, which is essentially our gateway to the network, our interface with the network. And then we've taken into consideration intelligence for enhanced decision-making. Now, the problem that we had, the legacy issue with previous telecom generations, was that you would be having a service and it would agree on an SLA, which means a service level agreement with the network. The network will be giving you a given set of options of what it can do, and then you as a service would have to agree with that and live with it. Now, in 5G, we also introduced AI, but that was running on top of the network with whatever data it could be using for inference and for suggesting decisions. Now, in a unified 6G application, you've got the proper interfaces between the service and the network through the NAP. So you are having privileged access to specific functions of the network, and you also have access to specific monitoring that comes from the network through the network application. Then, along with the context awareness that a service is offering you, specific to the vertical, you can gather all this information, and through an intelligent way, through AI, you can take decisions which improve both the performance, sustainability purposes, and it makes the whole system, the network and the service, to behave as one system that you can manage and control. And that is a major breakthrough with performance benefits, which can be translated, as we're going to see later on, into sustainability benefits. As said earlier, performance and sustainability do not by default go together, so we have to balance them. There are some trade-offs here which we have identified. Some of them are more obvious than others. We, for instance, have seen that performance may not always go well with energy consumption. Then might be having the usual questions of increasing the coverage, but this comes with a cost in terms of resource utilization, which can be also translated into a sustainability footprint. Then you got questions and the debates between reliability and operational costs. This is where the AI steps in. It evaluates your different objectives, tries to find the best compromise. Now, in our project, we have started from a design phase and a development of the 6G applications based on the format you've seen in the previous slide. Then we have been conducting 6G trials by leveraging existing state-of-the-art 6G platforms in different sites in Europe. And we have been designing those trials, targeting and concentrating actually on the principles of what a sustainable 6G should be. And last but not least, this goes together with evaluating the results of these trials, not necessarily and only focused from a technical perspective as we are used to as engineers, but also from a societal and environmental one, ensuring that there is an alignment between the technical objectives and the sustainability goals for societal needs. Okay, so we're not targeting a specific and only one vertical. We actually target 6 verticals with 7 use cases in 6 different sites in Europe. I will briefly refer to them. In Greece, starting from south and going westwise and northwise, we are having a pilot over there with collaborative robotics for search and rescue. So the vertical here is life-saving environmental prevention. The use case involves a scenario of a wildfire and preventing the wildfire or identifying the wildfire early enough, and also identifying potential victims with collaborative robotics. We've got the Bulgarian pilot that utilizes AI for AI-driven optimization of distributed renewable energy. We have the Spanish pilot, which targets smart agriculture with immersive telepresence actuator for field operations. We got the Portuguese pilot for a sustainable and safe port infrastructure. So this falls under the environmental and monitoring and safety. We've got the French pilot with 2 different use cases focusing on water management. One on data-driven strategies for water and waste management in critical infrastructures, so both freshwater and wastewater management. And last but not least, going to the north, we have in Finland an energy self-sustainable 5G base station. So without any guaranteed network, electricity network support, we have a self-sustainable 5G base station in some remote area that can survive on its own. This is the sketch of the reference architecture I referred to earlier, and I'm not going to get to the technical details of it. This is the general sketch which has been passed to the pilots, and based on their needs, it has been customly tailored to match the needs of the pilot. So we start from a common architecture. We start from a common framework from extracting KVIs and KPIs. This doesn't mean that the KPIs and the KVIs are the same. It means that the framework for extracting them is well defined, and then each and every individual pilot extracts its own KVIs and KPIs. We do have in common high-level objectives in this project, but the specific objectives depend on the pilot. And wrapping up everything, we started from a vision, which is sustainability. And then as we run our pilots and we run our trials, we have to translate that into actual measurements. So one way is through KPIs, which are the key performance indicators, and they are measured from an engineering perspective. But we also have the KVIs through questionnaires. So people that participate in those public open events in the trials, they are given a set of questions after which they go through, and based on the framework of extracting KVIs, we try to assess those KVIs against the answers that we receive from the questionnaires. So these are just examples of some first answers and statistics we got back from the Greek pilot. It's irrelevant from which pilot it is because I'm not going to get into the details. This is just showing that we are going through an analysis of the answers that we get back. And if we want to wrap up everything here, sustainability in our project is being treated as both an engineering and a societal policy objective. Trials are organized around the well-defined objectives. We have the usual KPI statistics measured with a technological automated way. And we also have a KVI framework, which is materialized through the questionnaires from trial attended stakeholders. In other words, participants which are involved with the topic of each and every trial. And we go through an assessment process following the events and the answers that the stakeholders are providing us in each and every case, in each and every pilot. That was it from my side. And thank you for attending this webinar. Now I'm going to pass the token to the next presenters for the real fun. Thank you.
Thank you. Thank you, Xenophon. So I'll pass the floor to Bernardo, who will first introduce the overall of work package 6, so the sustainability, and also talk a little bit more about this identification of the key value indicators, the KVI. And then you will go a little bit into the task related to environmental sustainability. So Bernardo.
Hello everyone, let me just share the screen. Can you see it? Alright, so, well, hello once again, my name is Bernardo Valente. I'm from the Center for Social Studies, as well as Rita from Coimbra, Portugal. And, well, over these next 20 minutes, I'll try to not spend that much time, and I have to apologize in advance because, well, my computer since yesterday is shutting down sometimes out of nowhere. So if I leave the meeting, well, I just ask you to be patient because I will eventually come back with a presentation if that happens. So yeah, what I will do during these 20 minutes is to walk you through the work package 6 and how do we approach sustainability in 6G versus, how we identify, assess the key value indicators, and how that whole exercise is actually based on European Union and global sustainability frameworks. I'll try to keep it practical. So let's start with this premise that drives the entire work package, because the name of 6G versus is 6G vertical trials for sustainability. And the core word here is sustainability, because our job in work package 6 is to assess the sustainability and also the circularity impact of technology. And then to do that we use key value indicators or KVIs, which benchmark once again based or against the UN Sustainable Development Goals and the targets of the European Green Deal. The key idea here is to understand, it's a value-driven approach. So it's not to understand if the technology performs well, it's actually to understand what is the value created by the technology. This can be in terms of the environmental area, the societal area, or the economics or the economy. And this is a main distinction to understand our methodology. So in terms of key features and key terms in our methodology, we have, well, Xenophon touched in some of those, but we start with a key value. So a key value is a core sustainability value that the project prioritizes. So it's basically what is the thing we care about. Then from there we have the key value indicator, and that's the metric, as you can see, is the metric we use to actually assess that value outcome, that value related outcome. It's how we actually measure it. And then the key value enabler, which is the technological development that makes the value possible. It's as the word says, an enabler. And then from there we have probably the most familiar one, which is the key performance indicator, the KPI, which measures the technical performance of the 6G technology itself, or the technology that the project is developing. So from there, let's understand how we move from KPIs to KVIs and this value-driven approach, as I was telling you. So the KPIs are mostly right? Are mostly quantitative, and they tell us how the system performs. And they are essential, and they are probably the most traditional approach, I would say, the most traditional approach to technology assessment. And then we move to the KVIs. So the KVIs try to go further, and try to go further in the sense that they try to capture the broader picture, right? To go beyond the technical performance and to assume that there are environmental, societal, economic consequences of this development, and these are, of course, or usually more qualitative, but it's very often possible to quantify afterwards. And if we take the example of this slide, for example, the number of people in remote areas now able to use smart agriculture services, that starts as a qualitative value, which is in broader terms inclusion, and then it becomes a countable indicator. It's possible to become a countable indicator. As I was saying before, it's very much tied, the methodology, to the EU and global sustainability frameworks, and that's the basis of our task 6.1, because we base our key values in these two external frameworks. I'll say, on one hand, the UN Sustainable Development Goals, and we looked mostly to the goal 13, which is the climate action, to guide our values on reducing carbon emissions in telecom infrastructure, for example. Then we also looked at the Sustainable Development Goal number 7, as well as number 17, number 9, which is the number 7 is affordable and clean energy, and the number 9 is mostly concerned on the resilient infrastructure and innovation, here probably speaking directly to energy and network dimensions. And on the other hand, we also looked at the European Green Deal. This is the roadmap, as we know, of the climate neutral economy by 2050, right? And here, once that we have the global goals, which is the Sustainable Development Goals, we moved to the Green Deal in this kind of operational translation for the European context, and it's this architecture that turns this ambition methodology into practice, because what we did was running the key values, or the elaboration of the key values, in two different steps. One about the legal, or in this case the sustainability frameworks, and the other one about the literature review, and to see what made sense or not to include in our analysis. Here you can see, well, very quick, this one, you can see a diagram where there is the KPIs and the KVIs. You can see that there is something bridging both of these approaches, which are the enablers, and the enablers are the technology that links what does the system do to create value, and this is basically the conceptual part of our methodology. And then to create the methodology roadmap, we can split this roadmap in two parts. We can split the roadmap in the first phase, which was months 1 to 6 approximately, and it was the literature review, also looking at the frameworks that I was telling you about, to draft the first list of KVs and KVIs, and then to build a unified framework and a common template, so that every one of the clusters that we have in the project can work in the same way, or to have at least a similar framework. So this was the finalization, or after that we went to the finalization of the KPIs and the KVI definition, so that we had all the 6 clusters aligned, and then we moved to the second phase amongst 7 to 9 approx again, and it was a trial integration. And as Xenophon said, now we have already the trials running, and we try to also refine the formulations against the real use case feedback. So this is the roadmap, and now let's go to the KVI identification process. So this per cluster identification, as I was telling you, comes first. So it's basically, we begin by understanding what we mean by KVs and what will be the basis of our KVs. So it was at the end the frameworks, the sustainability frameworks that I was telling you about, and then from in step 2 we went from the we use the KV alignment to use cases. So we map which values are common across the verticals and which are specific to a single use case. So we went with energy, environment, agriculture, water, safety, all components, features of our analysis. And then from there, we define the KVIs. We operationalize each value through we operationalize each value, and actually then we fix the data collection methods, and we end up with mostly surveys as our method, and that's what the trials are doing as well, to give questionnaires to the people so that they can answer and provide us with the data that will then align our KVIs or provide the answers for our KVIs. And then the step 4, of course, is validation with the stakeholders, understand what is feasible or not in each cluster, and then moving to the execution. So this is basically the map that I was telling you about, and this is a never-ending work, in the sense that we are always trying to monitor and refine our methodology and our KVIs as well. So as I was saying, this is always an ongoing work. Then from there we go to the root KVs, and how did we create the root KVs, and this is the second step of my presentation. We have identified the key values and the KVIs within each of the 6 practical cases, right? The alignment with the clusters, and after that, well, we had these rich context-specific pictures, 6 of them, mostly in different language. So it was important to wrap up, so to identify 7 root key values. And what are the root key values? Are the ones that recur across all 6 cases, right? That happen in all 6 cases, or that can be measurable in all 6 cases. And this is the crucial distinction. The cluster level KVs and the KVIs let us assess impact within each case study, and then the root KVs let us compare impact across the different contexts. It's kind of the line that ties all the 6 clusters, and then from there we found these 7 root KVs that you can see here, and we have, well, a more profound description of these root KVs here in this table. On the environmental side, we have these 2 KVs that you can see here, so ecosystem and risk resilience, and environmental footprint and reduction. Then on the social-cultural side, we have digital inclusion, quality of life and well-being, trust and cultural acceptance. And then on the economic side, we have optimized resource management and strategic cost reduction and economic value addition. So very quick, moving to the part of environmental sustainability and about the frameworks that I was telling you about in this first PowerPoint. Now moving to the second presentation. Well, the environmental KVIs in this case don't sit in this vacuum, so they are based in several environmental regulations. Some of them EU environmental regulations, or most of them. So you can see here the Nature Restoration Regulation, the Biodiversity Strategy for 2030. Don't forget about the main landscape, the main contextual framework, which would be the Sustainable Development Goals and the EU Green Deal. And then we looked also at the EU taxonomy, several frameworks and environmental regulations that could guide our work. Then from there we had these three main underlying causes. So that's some of the problem regarding the technology development and how that technology is applied then to sustainability, in this case environmental sustainability. Well, it's mostly because there is a disconnection from and domination over nature and people. So this disconnection between nature and people, there is a concentration of power and wealth, and there is also priorities that are a bit perverse, in the sense that in short term there is an individual and material gain. And from there we built 5 strategies, or we tried to in our methodology to guide our methodology through these five strategies for transformative change, because this is what these frameworks, these legal background that I just showed you. These are the 5 strategies, the 5 main ideas that can come out of these frameworks. And from there we can start with a conserve and regenerate places of value to nature and people, to drive systemic change in the sectors most responsible for biodiversity loss, transform economic systems for nature and equity, transform governance to be integrated, inclusive, accountable, and adaptive, and shift societal values and values towards human-nature interconnection. And of course, as all Horizon projects, 6G-VERSUS also tries to work on the 5 of them. Of course, it's always hard to check all the boxes, but that's the goal of Horizon program, and that's also the goal of the 6G versus ideology. So from there we had the EU Green Deal, as I was telling you before. So we can work very quick this one, and because this was one of the guiding lines of our architecture, and this is the overarching frame, as I was saying. It operates on 3 levels. It defines what is sustainable through the taxonomy, and it requires disclosure through the CSRD and the ESRS, which is a kind of a double material basis, and then it sets the binding nature targets through the Nature Restoration Regulation, and as well as steering products and trade through the ones that we are missing, which is the eco design and the CBAM. It's also important to mention, because it's a report focusing on the adaptations of policy and policymakers to this transformative change that we are seeing in terms of sustainability. And this time, so it's more scientific than regulatory, but the IPBES Transformative Change Assessment, adopted in 2020 and 2025, the leading thematic assessment on the underlying causes of biodiversity loss, and we have that in account too, on what it actually takes to change the course of this degradation that we have of our environment and of our sustainability in broad terms. And the core message is quite striking in the sense that the transformative change is a fundamental system-wide reorganization, as they see it, because it needs technology, economics, society, all these realms to work together, and that's the challenging part, so that we can have all the disciplines working together through this transformative change assessment, or through this transformative change course of action. And that's where it meets the EU policy. And I'm just finishing. Thank you for your patience. But before finishing, this is where it meets the EU policy, right? Both call for transformative, system-wide change, so structural change of the environment, or at least of how we see sustainability. And then they also see technology as the bridge that can help this new course of action. While IPBES names science and technology, the EU eco design rules and innovation funding push exactly that part, right? We see that we have more and more research projects based in this interdisciplinarity and also in the inclusion of technology and social sciences, the exact sciences, all in this kind of boat that we are working, that we are making that we are making work, in the sense that we are working for the same reason and in the same projects and with the same goals. Then moving to the mapping of 6G versus to environmental goals, we have mostly these goals, which is environmental footprint reduction, the efficient resource management, the ecosystem and risk resilience, the environmental monitoring coverage and data, and the stakeholder engagement and inclusion. And to finish my presentation, the last slide is exactly, well, I'm actually finishing where Xenophon actually finished as well, which is the cluster contributions. So we have Portugal with the ports and mobility, so environmental incident detection, renewable EV charging, smart lighting, longer IoT device lifetimes. In Bulgaria, we have renewable energy and high renewable uptake. We have Greece as well, with more of the civil protection part, the sense of wildfire prevention, safer emergency response, and we know that in Southern Europe we all need that. Then in Spain, the part of smart agriculture, which is basically water use efficiency, inclusiveness, and community health in rural areas. And in France, we have the smart cities, which is mostly about water saving, CO2, urban cooling, e-waste reduction through virtual models. And in Finland, the energy savings at remote times, renewable uptake, digital inclusion for remote communities, going back to the beginning, right, where we talked and I gave you an example of inclusion in agriculture. So these are the 6 very different contexts, and we try to bridge them all with this methodology and to make them comparable. And yeah, we are working on it and still working on it and planning to keep working on it. And yeah, on my behalf, that's it. I'll leave the floor to the next presenter, and thank you. And I'm glad that my computer didn't shut down during this time.
Thank you so much, Bernardo. I again invite you all to leave questions or comments in the chat. And now I give the floor to it's Shanaka Pereira and Mariam Irekeola, sorry, from University of Ubra and University of Kingston, to talk a little bit more about the social and the cultural dimensions of sustainability assessment. So thank you, Shanaka, for starting, and then you just pass on the floor to Mariam. Thank you.
Yes, thank you, Rita. So moving on to the social sustainability assessment of the 6G versus project. So as we have a general audience today, let me bring some context to what you mean by the social sustainability. So as you can see that the sustainability evolved around 3 dimensions, from environmental sustainability, social and economic sustainability. So in empirical literature, we find that in early 1980s and till mid 1990s, environmental dimensions being prioritized over the other 2 dimensions. But in late 1990, we can see the economic dimensions and social dimensions being also prioritized, but not as much as environmental dimensions. But in 2010, so we can see a drastic change in terms of prioritizing the dimensions. We can see all these dimensions are given equal importance in terms of sustainability assessment. So that is where we are in terms of these dimensions, and we can see each of these dimensions provide equal value for sustainable assessment. And moving on to how to define the social sustainability. So we don't have a concrete and consistent definition of social sustainability because maybe it relates to the context that we are working in. But in United Nations, we have this general definition of social sustainability. It is to identify and manage the business impacts, both positive and negative, on people. So as we are working on next generation technology such as 6G, so we can see social sustainability being recognized as that the people are at the center of innovation, ensuring that positive impacts are generated today as well as for the future generation. So moving on, why that social sustainability matters in next generation technologies. It mainly, if I point it out to mainly four points, so it reduces social risks. So as even at the designing and even in trials, we use these technologies, we embedded and address those social matters that are really concerned at the moment. So we like identify those social concerns and we planned our innovations through its designing stage as well as implementation stages, as well as it prevents any exclusions as well as inequality in terms of community. And also it increases the stakeholder acceptance. It develops the trust as well as the transparency of the technology that we are working on. And also it support responsible innovations, which means in terms of we get different perspectives, opinions from different set of stakeholders, from end users to different set of stakeholders that we are working with. So we inculcate all these opinions, perspectives into innovations, as well as these innovations are being driven as user-centered design. Then looking at creating long-term sustainability values, it supports the sustainable adaptation after being commercialized in these next generation technology. It is the sustainable adaptation to the community, as well as it develops and strengthen the social impacts that we are trying to make through these next generation projects. So then moving on to how do we assess sustainability, social sustainability in the 6G versus project. So as Bernardo clearly mentioned, so we follow the framework that we develop at the 6G versus project, and we identify the key values as well as the key value indicators, and then we have appropriate measurement techniques to assess whether we are reaching out to these KVs and the KVIs. So looking at the Bulgarian cluster, we are working in uh, renewable energy systems. We can see in terms of social sustainability, we are moving into, or we are addressing some key values such as digital inclusion, which enable these technologies to be accessed to remote communities in the society, as well as improving the quality of life, increasing affordability and stable renewable energy supply for the society, as well as social inclusion. As the technology being deployed, it increases the participation in energy generation in the community. So moving on to Finland pilot, so you can see that again the digital inclusion is one of the main social value that we have been addressing, providing the availability of 5G and 6G connectivity for the remote areas, as well as digital inequality. So these developed next generation technologies being provided regardless of living area, economic status, or gender or ethnicity of the community, as well as it improves the quality of life in terms of improving the reliable continuous 6G connectivity during even under disruptions. So these KVs and the KVIs that we identify for each cluster or the pilots are being context specific. So moving on to the Greek pilot, so where it uses more collaborative robotics in terms of regarding to matter the wildfire. So there in terms of the social values, we look at the quality of life. So where these newly developed 6G technology help us reduce the emergency response times in emergency situations, as well as it reduces injuries, casualties, involve people involved in the affected civilians, as well as the first responders of for those wildfire situations, as well as in terms of increasing the rate of rescue operation efficiencies, as well as better emergency preparedness. So these are some of the key values, the KVIs we identified from the Greek pilot that drives to the social sustainability. Then moving on to the other three pilots, the French pilot where we work with transparent 6G enabled AI alert system, so which improve the trust of the users of the technology, as well as in the Portugal cluster, it improves the quality of life, increasing the real time detection and prevention of abnormal events at ports and enhance safety and the environmental aspect of the port operations. And moving on to the Spanish pilot, where the quality of life being improved of the of these farmers who are involved in smart agriculture of the Spanish cluster, where enhance the awareness and the action on health issues among the agriculture communities. And then moving on to the SDGs. So we always map our social sustainability assessment into the existing SDGs, where I think the 6G and the SDGs are always going parallel, hand in hand, where the 6G commercializations are planned in 2030, as well as the sustainability SDG goals are being assessed again in 2030. There is a link between how these two dimensions are being operating. So we clearly identified social sustainability impact assessment of our project directly links to four sustainability goals. That is the sustainability goals 7, 11, 12, and 13 of the overall sustainability development goals. And yes, so that is in terms of the social sustainability. I'll hand over the session to Mariam to discuss about the cultural sustainability assessment of the 6G versus project. Over to you, Mariam.
Thank you very much. I'm just gonna share. Is it sharing as it is? No, I don't know. Let me see.
Yes, Mariam, you can see your screen.
All right, thank you very much, Shanaka. Yeah, thank you everyone. My name is Maria Marikela from King's University, and I'm going to be talking about, Shanaka has walked us through the social dimension, about access, who benefits and how the communities are being included. And I'm going to be building on that by going one layer deeper, because even when we talk about access, talk about the people that are included, there is still like a question that determines whether any of it actually sticks. And it's around does the technology fit the people it is supposed to serve, or are we asking communities to reshape themselves around it? So that question is what cultural sustainability is all about.
Mariam, just allow me to ask you to just put it on full screen because it will be easier for us to read. Yeah.
Okay. Okay. Right. So what does it actually mean for 6G to be culturally sustainable? And this is how we have framed it when we're coming up with the frameworks and how that Bernardo has discussed earlier. So a system is not culturally sustainable just because it is technically advanced. That's not enough. So it is culturally sustainable when people can recognize it. They can recognize it as appropriate, as meaningful, as something that fits within what they already have, what they already live, the way they already work, the way they're already governed, and then it makes sense of technology in their lives. Also, we have and that word recognition is very important because it is a cultural act. So it is not just about whether the system works or whether people can actually whether they can just look at it and say, "Oh, this makes sense in my own world. This belongs here." So we have also framed this around break it down to the four dimensions. The first is the cultural fit. And it is all around, does this system, does it align with how people already work, their routines, their language, their professional expectations? So it is not something like, oh, this is a new way of doing things, adapt to it. But so it is something around, something that fits into what is already available. And the second is legitimacy. We have do these people, does it like, is it trustworthy? Do they see it as something they can trust, as something that is worth engaging with? Because if this system is, if it's not something that people would trust simply, then they would not use it. So it does not even matter how technically brilliant it is. And also the third is institutional culture. So this is around, can this actually work inside real organizations, inside their real norms? Because when it comes to like a lot of systems now, they fail because they they maybe they just work technically because nobody thought about like how their institutions, how they operate day to day. And also the fourth one is continuity, which is around, does this preserve what communities have already built? Like their practices, their identity, their institutional memory. And I mean, as at now, everyone is going to agree with me that sustainability is not only talking about the environment. It is also about not erasing the things that matter to people in the process of like bringing something new. So those are the four dimensions. And so the next is going to be on how do we actually measure um any of this. So in 6G Versus, we translate cultural dimensions into the KVIs, into the key value indicators, specific measurable questions that make culture visible in our assessment process. Because we believe that if you are unable to measure it, then you cannot take it seriously as a sustainability condition. And the first question, I mean, the first is around, does it fit like local practice? So does this system support how people already work, how they communicate, how they coordinate, or does it ask them to change all of that to accommodate the technology? And this is something we saw across all of the clusters. There's a real difference between like a system that integrates into how pharmacies, for example, in the Spanish cluster now, my colleagues have talked about earlier, how they already manage their irrigation, or how in the Portuguese cluster, how the port operators already coordinate their work, versus one that is saying, oh, forget what you know. Here is how we do things now. The first one builds on the cultural fit, and the second one creates like a kind of friction that no matter the amount of training, it's not going to fix it. So I would say there that it is not a skills problem, it is a cultural mismatch. And the second one is around whose knowledge counts. So these are questions around like, are the knowledge systems of these local communities, of these workers that have been built up over years, are those being recognized as valid inputs that we are going to use in our design and evaluating all of these things, not just as user feedback, but that just gets processed and filed away, but as actual expertise that can shape things. And what we have found across the clusters is that cultural sustainability breaks down the moment you start treating communities as data sources rather than as people whose ways of knowing genuinely matter. And the third one is within the context. Now, this one is around, can we eventually make it work if people adjust their processes? Can it work as they are already as they already exist now, like inside their existing routines, governance structures, or maybe even their diversity of stakeholder needs? Now, moving to the So in Portuguese, for example, the cluster that has to do with port environment and the likes, it is one of our cultural KPIs here specifically ask, do these technology, this 6G enabled technology, does it actually fit inside the coordination culture of the port operations? It's not just about does it function technically, but more about can these support workers, can they actually recognize it as something that is that they can trust, that they can use, that is compatible with how they already operate, how they make decisions, how they communicate with each other day to day. So that is a cultural question, and you can only answer it by speaking to people, which is why we have gone through like the interviews and surveys method. And we intend to also go through the stakeholder dialogue as well for this assessment in the next phase of the trial. And by doing that, it signals, trust, legitimacy, fitness around what they already know. It does not just show up in the technical metrics, for example. They live in people's experiences of the system. So when we are able to ask them these questions, we are able to get their experience, the responses from it. Now to I think this is my last slide. Yes. The takeaway is the future of 6G can not only be faster or smarter, it also has to be culturally grounded. It has to be able to actually work across different institutional contexts, different local meanings, different human practices. And that is how technical innovation becomes sustainable innovation. Because think about it, if a system that works perfectly and communities do not trust, they don't recognize, they cannot see themselves in it, I don't think that is a sustainable system. And so I would say the question we should be asking is, and I want to leave you with, is we should not only be asking, can 6G work? We should also be thinking about or asking, can it be long as well? Thank you very much.
Thank you,
I
Manny,
think,
and thank you for leaving us with that very important question. I will now give the floor to Theodoros Vokas from Insights.
Yes, hello on my side.
Yeah, Mariam, you have to stop sharing.
yeah, I did.
Okay. And Theodoros will talk about the economic dimension of sustainability assessment.
Okay, so I believe you can see my screen. So I'm Theodoros Vokas from Insight Consulting, and the role we have in 6G Versus is that we are leading the tasks related to exploitation and commercialization of the project achievements, and also this task in work package 6 that has to do with the economic sustainability. So, as already mentioned by the other presenters, and especially Sanaka, so we have these three aspects related with sustainability: the social, the environmental, and the economic, that these three are interrelated. So in this presentation, we'll cover the economic sustainability, but as we will see later, there are some cases in which these economic aspects may also have impact in the other dimensions, in the environmental and in social sustainability. So first, trying to define what we mean by economic sustainability is this, especially with projects like 6G Versus, have to do with the future design, deployment, and also operation of the future 6G networks in an order that the total cost of ownership along with the value creation are balanced in the long term if we examine it, without having a negative impact in the other aspects in the environmental and the social sustainability. So it covers the full life cycle of a 6G network. So it has to do with aspects related to spectrum, such as spectrum sharing. It also has to do with reducing the cost for infrastructure investment for the related capex, to reduce the OPEX that includes also energy cost. And as we see, there are some increase in the energy cost the last year. So this is one of the most important factors that operators are trying to reduce in order to reduce their overall costs. Regarding the revenues in mobile networks, as we have seen the last years, with every new generation, customers can get so much offering from the operator without the revenues going up. Actually, the revenues from the operators are declining, so the operators have to find in this new environment some ways in order to add some additional revenue sources in order for their network deployments to be viable. And finally, we need, at least in this new version of networks, this new generation of networks in 6G, we have to have the ability for the whole ecosystem to be viable in order to be able to add more and more innovations. So the main drivers regarding the economic sustainability, so these are driven by the higher automation, the energy efficiency, and new business models based on the sharing the value. If we combine all these aspects, we should have a multi-stakeholder ecosystem that all of this in a combination can improve the return of invested capital that we have in this future 6G networks. If we check who can benefit from this economic sustainability, the obvious one is the infrastructure owners in the center of this figure that we have in the left. So, but furthermore, there are also other stakeholders that can benefit. Coming from, again, the infrastructure owners, we mentioned by this the mobile network operators and also the private network operators. We have seen from 5G eras that we have industrial private networks, some networks in ports and university campus whenever they have the infrastructure, so they can benefit for the achievement that we mentioned earlier in order to minimize the total cost of ownership and energy consumption of the network. Also, if we look to the figure to the left, as we expand the beneficiaries, we also expand the value and the impact that they have. So we go now to the digital and over-the-top platforms. This can monetize the resources they have, for example, edge cloud computing, data centers, AI, or orchestration platforms. That all these digital platforms can sit on top of 5G and becoming a central point in which we can develop some new 6G software business applications. There is also value for the vertical industries, such the ones we will see. We have already seen from the previous presentation that we examined in the project and also other verticals. So what they can gain some improved productivity, safety, sustainability improvements from all the nice things that 6G provides. And finally, we also have benefits from the society. So this include apart from economic impact, so that has to do with the coverage. We have resilient critical communications. We have digital inclusion. And also, we can cover also in environmental aspects by enabling, for example, the decarbonization of energy networks. With all this, we have the creation of new value chains. We have now we transition to platform-based ecosystem in which connectivity, computing, and data are all created and shared among the telecom cloud providers and the verticals. All this requires some open value configurations that are under modular architecture, some standardized APIs, and revenue sharing agreements that allow many stakeholders to innovate. And we are moving from a single operator CapEx-driven rollouts to multi-party investment models and platform in which all the capabilities are used to develop industry-specific solutions and develop the appropriate services. So these drivers for the sustainability is the reduction of energy, reduction of total cost of ownership. These are made through the improvement of the energy efficiency. That it's paramount to have it because we need to intensify the network, so we need a lot of new deployments. There are platform and sharing models that has to do with the sharing the infrastructure from a spectrum of platform, and that this allow the CapEx reduction and better utilization of the assets. As already Xenophon mentioned, one of the key aspects that is also applied to the 6G Versus is the sustainability as design principle that includes sustainability and inclusiveness of the high-level requirement for upcoming 6G systems, and also technology-driven drivers, like the one again that Xenophon mentioned that has to do, for example, with the triplet that 6G offering and allows the creation of new services for the verticals. So what's to do, how we work about the economic assessment in the project? Already Bernardo mentioned about the methodology. We're going to focus here on some high-level KPIs. So we have first the horizontal assessment that has to do that it's activity that covers all the clusters. It has to do with the efficient resource management and also the cost reduction and economic value additions. All this apply to all of the clusters, and we are going to try to measure all of this. And then if we go by cluster, first we have the Bulgarian cluster that it's mostly focusing on distributing to monitoring and control of distributed renewable energy sources. So what can be the economic benefits associated with this cluster has to do with optimized revenue management for these owners of the renewable energy sources, and also to the reduction of investment for connecting these renewable sources, because in most of the cases these are in areas that are undercovered, for example, in rural areas. Going to the Finnish cluster, this is mostly related to the self-sustainable 5G base station. So the ambition is to have a base station that can be deployed even in low density populated areas and that usually don't have access to the power grid. So this new base station can reduce all the costs that is associated with the deployment of the base station, and most importantly, of the cost of maintaining and having the cost, reducing the cost of eliminating, to be more precise, the cost of energy. And by enabling the connectivity in these underserved areas that are usually not connected with high capacity networks, we can expand the ecosystem to include revenues from new businesses that are going to use this network to provide services in these remote areas. The Greek cluster has to do with collaborative robotic search and rescue activities. So instead of having, for example, patrols going through the forests and trying to identify possible fires or any other dangers, we can use robotics or UAVs to be deployed and provide imagery and support and provide all the information that is needed to the operations center in order to make the correct decision. So we don't have a need to go, for example, to fly with helicopters or have these foot or vehicle patrols inside the forest. So we can reduce the cost associated with this. And also in some cases where it's difficult to have connectivity, we can deploy some UAVs that can act as relay nodes in order to extend the connectivity and provide the ability to have an overall overview of what is happening and provide the appropriate solution. In the French cluster, we have two use cases. The first one has to do with sewer and network monitoring. So the purpose is to improve the urban water management. So we have better management. We of course to have to reduce the leaks in the network, also reduce flooding risks. So we have a reduction of the associated costs. And also in the second use case that has to do with the smart watering green spaces. So the purpose is to optimize as possible the irrigation in some areas by using all the sensors that are connected through 6G. And we can reduce significantly, the purpose is to significantly reduce the water consumption to improve the plan of the health. And we have to some increase the return of investment from all these investments related to sustainability. The Spanish cluster has to do with immersive telepresence actuator for field operations. So we can the cluster we want to enhance the sustainability in agriculture and water treatment, let's say, environments. So we have the cluster can develop the solutions that can improve the telepresence in the field operations. So they will have a reduction on the need for physical traveling to the farm to do inspections or other works. And also we can reduce the carbon emissions that have to do with that activities. And furthermore, using this automatic harvesting and monitoring of the crops, we can increase significantly the productivity of the farm. That it's a direct economic benefit for the farmers. For the Portugal cluster, it has to do with sustainable and safe port operations, which inside the port we have a lot of logistic companies that operate. So having a center that can organize all these logistics and have a center that can scale the computer and network resources in order to improve all the operations related to the port operation. And also, as in most of the use cases, the energy consumption of the infrastructure is one of the main points that is covered also in this cluster. So what are the next steps? This goes to all the assessment for all the aspects of sustainability. So we are in the process of collecting input from the trials that are actually happening in all these clusters. The next step is to validate the results, and at least for our aspects to try to estimate the direct economic impact that each of the cluster has, along with the indirect economic impact that is associated with each of the clusters. And that was my last slide. So I'll pass the floor to Rita, I suppose.